Okay, Lecture 5, Measurement and Significant Figures. Know those definitions, and that will help with these problems here. What two things are necessary for when writing the result of a measurement? A measurement must have a number and unit of measure. So let's say that I tell you I live from the school, I live 50, or say 53. Now, if I mean miles, then that's pretty far away. If I mean kilometers, it's a little closer. If I say I mean meters, then I live across the street. You don't know. I have to put it in here. So let's say, there we go. Now we know what we're talking about. And you can never assume that, you can never say as a scientist, well, everyone knows what I'm talking about. No, you can't say that. You have to always have the number, unit of measure. Can one measurement be considered accurate? Can it be considered precise? One measurement, if you looked at the definitions, accuracy means how close one measurement is to the true value. So yes, one measurement can be considered accurate. Can it be considered precise? Precision is about how close a set of measurements are to each other. They have nothing to do with the true value, just how close they are to each other. So it's the repeatability of the measuring device. So you can say yes here and no to precision. Has to be, for precision you need two or more measurements, and the more the better. Okay. 3. We have a thermometer. Is used to measure the temperatures of a beaker of hot water. And it was found the true temperature is 35 degrees Celsius, found with a type T thermocouple. Just that the reason I use that is because it's measured down to 0.1 degrees Celsius. You're never off by more than that. So 35, when it says 35 degrees Celsius, it's pretty much that. In this range here, and 35 degrees Celsius is in that range. So we take a not quite as accurate thermometer, most likely. It's not going to be as accurate as a thermocouple, and we take 4 measurements. And we do it before the water cools significantly. Describe a set of results that you would have low accuracy and high precision. So if we had, let's say we measured it and we found that it was 14 degrees Celsius, and then 15 degrees Celsius, and we measured again, and we come up with 14 degrees Celsius, and then 13 degrees Celsius. That's a pretty good, pretty high precision. And it, again, let me just say that it depends on what you're looking for here. Being off by 1 degree might be very low precision for under some circumstances. But for us, in a regular lab setting, this is pretty precise, but you can see that we're way off from what the true value is. So low accuracy because we're nowhere near the 35 that it should be, but high precision. And believe it or not, this is actually okay as long as the thermometer comes up with the same kind of reading each time. All we have to do then is add 20 to it. You think, well, that seems like cheating, but it's done all the time with machines, and a lot of machines automatically do that. They auto-correct. They're very high precision to start with, but maybe their accuracy is way off, and then you just adjust by whatever amount you have to. High accuracy and high precision. Well, this is where we get the best of both worlds. Let's say something like this. Measured out. Nice. It's a nice cluster, a small spread, and around the true value of 35 degrees Celsius. Low accuracy and low precision, that's everything is out the door. It's something like this, where you're nowhere close to the answer, the correct answer, and it just jumps all over the place. When you have a device that does that, throw it out. There's nothing to be done with this device, or something that's gone horribly wrong. High accuracy and low precision is a little trickier to do here, but it'd be something like where we have 33, and then we jump up to 37, and down to 34, and then to 36. Looks a lot like the high accuracy and high precision. It's a little trickier to do because we have to the high accuracy means we have to stay near the true value, but low precision means it has to jump around. So this one is a little trickier to do. That's the basic idea. So you are asked to measure the length of a pencil in centimeters and then to determine which digits of your measurement are certain and which are uncertain, and how many significant figures you have for your measurement. So I just drew this out freehand, but you get a basic idea. So we have the ruler set at the end of the pencil, and here you can see the eraser hits about this mark. Well, the numbers are tell us the certainty here. We go all the way down to 12. We know for certain that it's 12. We also know for certain that it's not 13. It's less than 13, it's greater than 12. Now the uncertainty comes in where we don't, most rulers would have had little divisions in between, but let's say this is just a little kitty ruler. And that's as far, so this space in between, there's no markings. So that would be the uncertain. That's our guesstimate. You can see that it's greater than, looks like it's greater than 0.5, so I'd go something like 12.6. Other people might look at it and say, oh, it's 12.7. So that's where there's uncertainty. And so what we have are three significant figures. I'll just write it SF. We have two certain and one uncertain digit. So these are certain, and this is uncertain. And that noise you're hearing is the cat who is playing around. And that's it. So any measurement that you have, you're always going to have one uncertain digit, no more than one uncertain digit. That should be pointed out. The rest, you'll always have certain digits, as many as you can get in for your measurement, and then there'll always be one that's an uncertain digit, either where you're guessing or the computer is guessing. There's the variability in that last digit, and it's allowed in there because even though it's uncertain, there is still some information to be gained. If we left it as just 12, well, that's true. I mean, we know it's somewhere between 12 and 13. But here, even though it's kind of a guesstimate, it gives us a better idea. So that uncertain digit is left in there, not because it's not completely uncertain. There's something to be said for it. It's not just jumping all over. There is a bit of information there.